Good morning, everyone. This is Professor Vishal Gupta with BUAD 425, Data Analysis for Decision Making at the USC Marshall School of Business. This video is an addendum to our last class, Intro to A-B Testing. In some of my sections, I had to rush through the last 10 minutes, and I wanted to just review them for everyone so that you had some time to look at them on your own. Just as a reminder, where were we in class? We were looking at this situation of the red button, green button, and which one we should choose. And I'd given you three alternate situations. Situation 1, where we saw about 40 data points per button, and we had computed that the difference in average was about $2. The standard deviation was about the same. It was about 20 points per button. Situation 2, where we had a much smaller difference in the averages. The green button was about 30 cents bigger. The standard deviation for the red button was not very large. There's still about 20 points per button. And situation 3, where the differences in the button again made the red button better again this time, by about $2. Standard deviation was still quite large for the red button, but now I had quite a lot of data points. When we had gone through these in class, we had talked intuitively about which button to choose. And we had said in situation 1, because the average is better, we like the red button. And when I asked most of my classes about how confident they were about the situation, the answer was usually something like reasonably confident. In situation 2, I had asked which button to pick, and most of my classes again said because the average is better in the green button, I would choose the green button, but I'm not quite as confident, or I'm not confident. And this was because the variability was quite high. And in situation 3, when I had asked, which button would you pick? Again, most of my classes had said, choose red. And I asked how confident. They said, well, I'm more confident than I was in situation 2 because I have a lot of data points. But I'm still not that confident because I have this really high standard deviation. So today what I want to do, and I did at the end of class last time, is to show you how to use the formulas for the z-statistic and p-value to take these intuitions, which are all correct, and turn them into formal mathematics. Okay, so let's go back to situation 1. The first thing I'm going to do is I'm going to use the formula for the z-statistic from the slide to compute the z-statistic. As a reminder, here's the formula, and I'm going to write equals the difference in the averages. Remember, I always do the second method first, divided by the square root of this standard deviation squared, divided by n, plus this standard deviation squared, divided by the count. Okay, and remember, bigger z-statistics mean that there's more evidence that the second method is better, and I can make that formal using a p-value. So I'll type norms dist minus z. Okay, so how do I interpret these numbers? Well, it says that for this first situation, we'd intuitively chosen red. And what the mathematics tells me is that if I did choose red, there's only a 1% chance that I had made a mistake. Okay, so that's pretty good. And so this notion of reasonably confident, we can make it formal now, instead of having this squishy qualitative idea, and say instead that there is a 1% chance I made a mistake if I chose red. And why red again? Because when we interpret the p-value, we always interpret the p-value as choosing method 2. So I can do the exact same computation in situation 2. What I'm going to do to be clever is just copy over my formulas from situation 1. And now what I see is a little bit more subtle. So the first thing to notice is that the z-statistic is fairly small. The consequence is that the p-value is sort of large. Now remember, how do we interpret this p-value? The p-value again is, suppose I had chosen red, then the probability that I would have made a mistake is about 52%. i.e. it's just about as good to flip a coin, and so the math is telling me that there's not a really good reason to choose red. Remember, if we think back to our intuition was, well, choose green, but just because it's sort of marginally better on average. And in reality, we're not very confident about that. What do I take away from this example? Well, for this choice of data, the p-value is pretty close to 50%. So it's basically a 50-50 coin toss about whether or not red is better than green. Another way to say that is that I'm not super confident in what to do, and I need more data in order to decide. All right, and finally we can look at situation 3. Again, I'll just copy and paste the formulas here. And in situation 3, we can see that, okay, we have a pretty high z-statistic, pretty low p-value. Our intuition was to choose red, and the p-value tells us if we indeed did choose red, the probability that we had made a mistake was very small, 0.01%. So here we see that the value of the extra data really did help quite a lot. So to summarize, I want to make sure that everyone understands how I did this computation. Please go through and reproduce it. This Excel sheet is available online, and make sure that you can compute both the z-statistic and the p-value for these examples. You'll need it for your pre-case for next week. Please feel free to send me questions if you have them, or we can chat about this in class. Thank you so much.